in the figure above, right angle ABC has legs measuring 15 in x, and right triangle ADC has legs measuring 7 and x plus 4. What is the length of segment AC? All right, this is another kind of tricky geometry problem we have here. And if you notice, we have the two right triangles, all right, which means we can use, SOHCAHTOA if we have to, which we won't. But we're going to be using the Pythagorean Theorem. And because if you also notice, both these triangles have the same hypotenuse, which is AC. So if a squared plus b squared equaled this, and x plus 4 squared plus 7 equaled that, we can just cut out the middleman, that, and we can set 15 squared plus x squared equals, and instead of, c squared or y squared, if we let it equal that, we're going to let it equal the other two squared. X plus 4 squared plus 7 squared. Okay, and then we're just going to simplify here because we want to solve for x. So we're going to have 225 plus x squared equals, what's that going to be? X squared, multiply these, double it, plus 8x. 4 squared is 16 plus 49. Okay. Let's see here. We can go ahead and cancel out the x squareds, right? We can subtract those, so they're gone. We can, you just subtract 1 from each side and you'll get it. And let's see what we want to do here. We'll just go ahead and carry it down. 225 equals 8x. And what's 16 plus 49? That would be 50, 65, right? Subtract 65 from both sides. What would we get? 160 equals 8x. Divide both sides by 8. And we get what? 20 equals x. All right. We got it, didn't we? Wrong. 20 is not the answer. What we have to do now, is plug this back into whichever one we wanted here. And then do the Pythagorean Theorem again. To figure out what this is. Because x equals 20, we don't want to know what this side is or that this side is 24. They still want to know what the hypotenuse is. See, this one is trying to trick us yet again. So, all right. I'm just going to choose the first one here. The 15 squared plus x squared equals, well, it's going to be plus 20 squared now, but equals c squared. So, okay. 15 squared plus 20 squared equals c squared. Okay, and we got our 225 plus 400 equals c squared. 625 equals c squared. Radical both sides. And what do we get? What is the square root of 625? You're exactly right. It would be 25 equals c. So after all that, we finally came to the conclusion that AC, which is the hypotenuse for both of these right triangles, the hypotenuse is 25. All right, good job if you guys got that one. Way to go. A line segment in the xy plane with endpoints x4 and 2x10 has a midpoint located at 12 x minus 1. What is the value of 2x? For this one, we're going to use the midpoint formula, which, if you remember, is x sub 1 plus x sub 2 divided by 2 over y sub 1 plus y sub 2 over 2. You can just think of it as you add the x's, divide by 2, add the y's, divide by 2. And that's how we find the midpoint between 2 points. So using this formula, we're just going to put those points they gave us, which they gave us the points, let's see here, x, 4, and 2x, 10. So, okay. We're going to do x plus 2x over 2. And then 4 plus 10 over 2. Okay, so this simplified is going to give us 3x over 2. 4, well, no. What's 14 divided by 2? That would be 7. Okay, but that's not the answer, right? It still wants to know what the value of 2x is. So we just kind of got that as a means to an end. So that is the midpoint that we came up with these 2 points. But the problem said that the midpoint was at 12x minus 1. So what can we do there? We can just make a proportion. The problem told us it was at 12x minus 1. Okay. The easy thing would be to use the y here. What minus 1 would give you 7? Well, 8. I mean, we could also make a proportion. 3x over 2 equals 12. And put that over 1. And 3 times 1, 3x. 2 times 12 is 24. 24 divided by 3 is also x equals 8. And there you go. You can stop there. That's all they wanted. Oh, no, hold on. I just remembered. They wanted to know 2x. Because, see, these tests are always trying to trick you. So if x is 8, 2x equals 16. Yep. I almost got tricked there. I don't like to be tricked. I pity the fool that doesn't watch, subscribe, or like this video. I'll see you next time.